Good evening, all. Welcome to Spark Academy, and today we are going to discuss about a new topic, that is capacitors. Okay, we'll wait couple of minutes to everyone to join, and then we will start this capacitors. The first part of capacitors today we are going to discuss. Okay, so in our last classes we have studied about the potential and electric field, and we have also discussed about few problems, few numericals, how to solve the numericals and all that, right? We have studied about how to solve the numericals in the electric field. Numericals which are related to force, Coulomb force in the electric field, and the numericals which are related to potential, the numericals which are related to the vector forms of electric field and potentials, and all that we have studied in our last classes, right? So this class, this particular session, we are going to learn about the capacitors, okay? And how can you find out the energy storage in the capacitor and all that we will learn in this session. As I told you, we'll just wait for a couple of minutes and then start the session. Yes. So, yeah. So before I start the session, this is Anupama, physics lecturer, and today we are going to study about the topic capacitors, that is 1. Capacitors 1. Yes, as I told you, this particular session you are viewing from the Spark Academy's YouTube session, and you can join the free live classes every day. For that, you need to download the Spark Academy app or subscribe to the Spark Academy YouTube channel. You will have daily live classes, and in the YouTube, doubt clarification will be there, and once you download the app, you will have free material, free study material, tips and tricks, and the previous year's questions, also solved question papers are also available in the app. Okay, so just download the app, and short-term courses, long-term courses, classroom and online teaching, everything is available in the app. So just go to the Play Store, download the app, and then you will see all this. Okay, download the app and then you will have this. So as I told you, every day YouTube live sessions will be there, and this is the timetable of everyday YouTube live, 11 to 12, 5 to 6 and 6 to 7. And Monday, Tuesday, Wednesday you can join for my classes, that is physics classes by me, that is Anupama. Okay, and in this, I already we have started this long YouTube sessions long back, and then we have completed current electricity, and this is electrostatics. We have also completed optics, or we will be completing even the optics by the end of this month. So For any doubts, you can just write down in the comment box, and you can join my YouTube classes every Monday, Tuesday, Wednesday, 6 to 7 live, right? So to enroll the courses which are offered by Spark Academy and to get the discounts on the Spark Academy, you can use my coupon code, that is ANU. Okay, ANU10. You can use this coupon code and get the discounts which are offered by Spark Academy. Okay, so as I told you, today's session you are going to learn about the capacitors, electric capacitors. Okay, so as electrostatics, this is the part of electrostatics, and as electrostatics has 6% of the weightage, even these capacitors, also few problems may be covered from the capacitors here. Okay, so capacitors, this is about the capacitors. Capacitors are the ratios of potential, charge to potential. Capacitors are the ratios of charge to potential, and which is given by C. One second. Capacitors are the ratios of charge to potential. That is C is equals to Q by V. What is the unit? The unit of Q is Coulomb by unit of V, that is potential, is volt. So Coulomb by volt is nothing but Farad, which is the unit of capacitors. Okay, so we have a parallel plate capacitor here. The parallel plate capacitor, if you take parallel plate capacitor, consists of two parallel plates which are actually charged. The charged parallel plates which are placed at a distance of d from each other. Then what happens here is, usually when two parallel plates are placed which are actually the charge at a distance of d, then now in this particular parallel plates, a thickness of some T thickness of dielectric slab we are introducing, for example. Then the parallel plate capacitors capacitance, usually it is Q by V, but now as we are introducing a material, a slab of dielectric constant K, every material will have its own dielectric constant. So now when you are introducing a slab of dielectric constant K and the thickness T into this, in between the space of two parallel plate capacitors, then the new capacitance is given by, the new capacity is equals to epsilon naught A by D minus T into 1 minus 1 by K. Okay, so this is how the parallel plate capacitors can be, capacitors of the parallel plate capacitor can be found by using this particular formula. Okay, so today we'll just, on the whole, we'll complete the synopsis part, and then tomorrow we will start doing the problem, so that what happens is, like, you will also come to know how the problems can be solved. Okay. Right. Now let us suppose there are two dielectric slabs of equal thickness. Now in the previous case we have taken only one dielectric slab. Now we are taking two dielectric slabs of equal thickness, which is of K1 and K2. Okay. And we are introducing here. Then the new capacitor, as shown in the figure, we are introducing two parallel plate capacitors of this of same thickness. As I told you, this is, let us suppose this is A by 2 and this is also A by 2. Then the new capacity in this case is given by, new capacity is equals to C by 2, the original capacity C by 2 into K1 plus K2. This is how the capacitance changes, right? Now, for example, different areas we are taking. Like here, we have taken only the same areas, isn't it? Same thickness. This I said, same thickness means area will be same. Now, if I am taking two different slabs of different thickness, then the new capacitance for different thickness or different areas, A1 and A2, then the new capacity is given by C is equals to epsilon naught D into K1 A1 plus K2 A2. So this is how the new capacitance is given for a parallel plate capacitor when two different slabs of different dielectric constant and different areas are introduced in between the two plates which are separated by a distance d. Okay. Now in the next case, for example, if two dielectric slabs of constants K1 and K2 are introduced into the slab, then how it will be, like introduced into two different what do you call that as, like in the previous case we have taken this as D, right? Now we are dividing D and now we are taking K1 and K2. Now what happens, let us see, like this. If you see the diagram, you'll come to know. Here one slab I am placing, this is K1, another slab which is K2, different slabs I am placing, and then this is D by 2 and this is D by 2. Area is same. So in such cases, means horizontally you are introducing. In the previous case we have introduced it vertically side by side. Here it is up and down, so D is changing. I mean the distance between the two plates, now it is divided. In such cases, the new capacity is given by 2K1 K2 by K1 plus K2 into C. So this is the new capacity when you are introducing the two slabs of different thickness like this. Okay, right. Yeah. Now like this, for example, here we have taken only two. What happens to the capacitance of the capacitor if n number of slabs are introduced in this way? So obviously what happens is, if n identical slabs are introduced into this, then we get 2 to the power of n minus 1 different capacitance here. So here we have taken only 2 and then we have got the new capacitance. But if n identical slabs are given, then the capacitance definitely will change and the new capacitance will be 2 to the power of n minus times of the original capacitance. Okay. So this is about the capacitance for n number of slabs. Now if you can n number of identical condensers are taken, each of capacitance and are connected in series and parallel, what happens, let us see. When they are connecting in series, okay, or when they are connecting in parallel, like I think usually the symbol of capacitance is two parallel lines like this. Now when you are connecting the capacitors in series and parallel, capacitors in series and parallel. series. How will you connect them in series? Like this. Oh, sorry. Okay. How will you connect them in parallel? Like this. One below the other. I am just drawing, the symbol for battery. I think you know the difference, right? In battery, we will have one positive terminal and one negative terminal. Bigger line indicates the positive terminal and the smaller line indicates the negative terminal, isn't it? But here in capacitors, it is two parallel lines, which are equal in size. That is the difference between the capacitors and batteries. Okay, I am by mistake, as I'm used to draw the battery symbol, then that is only coming here. Don't get confused. These are the capacitors. I am trying to draw. Uh, I am trying to draw capacitors only. I don't know. I hope you are understanding this. Otherwise, we'll do one thing. We'll just change the color. Yeah. If I change the color, then you'll come to know actually what is a capacitor. Now, what I'll do is for red, instead of red, we'll choose yellow. Yeah, yellow. Yellow will be visible, I suppose. Yes. See, battery I am drawing here. Yeah. Yes. Now I think you can. This yellow is looking pretty good on green. Yeah. See, I think you all know this. The colors are always beautiful, and then the story of colors is wonderfully explained by dispersion of light, isn't it? Dispersion of light, and that too again physics only, isn't it? I hope you know this very well. You have studied in your earlier classes, especially in 10th class, I think. The dispersion of light, and then because, and not only that, because of the refraction through the prism also you get different colors again. Yeah, these beautiful colors are again because of that only. Yeah, this is how we connect capacitors. We'll go back to blue again. This is how we connect the capacitors in series and parallel, right? So now when they are in series, what happens is in the series connection, Q is same, right? Charge is same. What will be different? V is different. V is different, right? So from C is equals to Q by V, Q is same, isn't it? That is, C is inversely proportional to it. So when you want to know the effective capacitance of or equivalent capacitance of this particular circuit, then you get 1 by C is equals to 1 by C1 plus 1 by C2. This is reciprocal, you will get. And then when you take parallel connection, and then I mean this is parallel connection, yeah. And then if you take the series connection, then you get the capacitance. What will be there in series? C is Q is same in series, and in parallel it will be V, right? V is same. So you get in series, you get C is equals to C1 plus C2 plus so on. And here you get this is parallel. Yeah. I have to tell this before, but somehow it got to see. So this is how capacitors are drawn in parallel and in series connection, right? Okay. So what happens to these capacitors? Like, how do they act actually? I can say capacitors are the energy storage devices. Capacitors are energy storage devices. Meaning what? They are they are used to store the charge, or they are used to store the energy. Okay. So this is how the capacitors are actually used. Okay. Where the charges are stored, and where you need to require an external source to start something, these capacitors are useful that way, right? Now, yes. So now what happens to the energy in the capacitors? Let us see. The energy in the capacitors are, will be energy stored in the charged condenser or charged capacitors, will depend upon the strength of that particular capacitor first thing, and also the potential here. So now we will see the possible formulas which are possible for to find out the energy here, energy of the capacitors. Yeah, this yellow is pretty good. I will draw the underline this. Yes, yeah. So, what will be the energy stored in the target capacitor here? Acha, before we go there, we have studied about the parallel and the series combination here, isn't it, right? Parallel and what happens when n number are connected in series? N number of capacitors are connected in series. In series connection, n number of capacitors, equivalent resistance or effective capacitance is given by, in series connection it is given by C by N, and effective capacitance in parallel connection is given by C effective is equals to N into C, N times of that of C. Okay, so this is about the parallel. Sorry, this is series, right? So in this way, the n number of capacitors, it's like resistance only, but reverse to the resistance. Resistance, we have got series as R is equals to R1 plus R2 plus R3, and in series, and in parallel it is R by N. But here it is different. Okay, in series it is C by N, and in parallel it is N into C. So this is about the capacitors when they are connected. N number of capacitors are connected in series and parallel. Now let us take energy storage in the capacitors. The energy stored in the condenser is given by U is equals to half CV square. So this is the energy stored in the condenser. Now from the formula of C is equals to Q by V, if you put in place of C this Q by V, let us see what we will get. Half Q by V into V square. This one V will go off. Then you will get U is equals to half Q into V. Okay, half Q into V. Or in terms of capacitors, if you want to you have to remove, if you want to remove V from this, you can write V is equals to Q by C. Now I'll put this here, then I get half into Q by C, so which is nothing but Q squared by 2C. So these all are the possible formulas for energy stored in the capacitors. Okay, so this is about the energy stored in the capacitors. Now, as I told you, you are viewing this particular YouTube live session from the Spark Academy, and just go subscribe to the Spark Academy, and then enroll all the all the courses. You can see there, short term, long term, and everything. And whatever course you want to join, just click on the link, use my coupon code, and get the discounts by using this Spark Academy app. Okay, so go to the Play Store, type Spark Academy, install, download the app, and get the discounts on all the courses which are offered by Spark Academy. Once you download the app, you will see the home page just looks like this, which consists of free handwritten study materials and handwritten notes, printed study materials, previous year question papers, free mock tests, all will be there in the home page of Spark Academy. Okay, now you can just go, there will be a link available. You can just go to the link in the subscription, link, and click on the link. Then it will direct you to the courses which are offered by Spark Academy. Long-term courses, crash courses, previous year solutions, full-length test, study materials, mock tests, whatever you want, you can buy. And as I told you, you can buy on a discounted rate by using the coupon code, that is ANU10. Okay, right? And then these admissions are open now. Classroom coaching and offline coaching is available. And classroom coaching, we have short-term coaching from 10 to 4 and regular coaching from 6 to 9. Okay, crash courses are also just starting. They are coming very soon. And we have even online coaching also. Online coaching, we have NEET 2020 online, JEE Mains 2022 online, EAMCET 2022 online. So what you will do here, you will just go, click on the link which is in the description, and then type ANU10 on my coupon. You will get the discounts there. Okay. So this is how the sessions will be, like this is how the courses will be. Now daily courses, daily and on-demand live sessions will be there, and every day online offline coaching will be there. And in the app, the recorded videos are also available. Even if you miss one class, then with the help of the recorded video, you can just listen to the class again and again in number of times depending upon your requirement. Even if you miss, you can go any day, you can just open the app and listen to the class, right? So that you will not be missing any of the classes. Okay, now okay, right. So here we have common live session, as I told you, consists of assignments. Everyday assignments will be available, and then you can see how the assignment looks like. Test papers are there, and then once the test details will also be there here, like grading system and the analysis and statistics, everything combined. You will get the test results like this. So what is our methodology of teaching? Our methodology consists of basic concepts, shortcut methods, All model questions will be discussed, exercise questions will be discussed, previous year question papers will be discussed, chapter-wise tests will be discussed, tests will be conducted, and test paper solutions will be posted in the app, right? And then weekend tests will be there, grand tests will be there, and test analysis. So why only Spark Academy? Because we have highly experienced faculty, personalized teaching, process-oriented coaching, personal mentoring and doubt clarification, and above all, it is the limited batch size. Yeah. So when you compare our offline and online teaching, you can see access to the classroom. Online anyways it's not possible, and access to online both, even in online offline both, it is possible. Books are available for offline coaching. Online coaching, the study materials will be there online. Okay, weekly tests will be conducted for both the sessions, grand tests will be conducted for both the sessions, and doubt clarification for both the sessions. Doubt clarification in person in the classroom coaching obviously, and yes, online mode for the online coaching. Okay, so this is about the Spark Academy app. Right now, where we left, we have been discussing about the energy stored in the capacitor, and we have got different formulas like U is equals to half CV square is equals to half Q into V is equals to Q square by 2C. Okay, so this is about the energy stored in the charged condenser. Now, what will be the loss of energy is common potentials in all the cases. Like, for example, when you are connecting two charged bodies which are carrying Q1 and Q2 charges, two charged bodies are there, and the charges of two charged bodies are Q1 and Q2 having like charges. Anyways, it is only repulsion like charges, and having capacitances as C1 and C2. Okay, C1 and C2, and they are connected with each other. So then what will be the common potential here? The common potential in this case is given by Q1 plus Q2 by C1 plus C2. Here V is nothing but the common potential. Common potential for two charged bodies when they are connected with Q1, Q2 charges and C1, C2 capacitors. Okay, so this is, otherwise you can write even like this also. C1 V1 plus C2 V2 by C1 plus C2. Right? So, V1, V2 are the initial potentials of the charged body. Means before you are connecting them, these V1 and V2 are the initial potentials. Okay, now once you combine it, you get a common potential. I hope you understood this, right? So the loss of energy, in this case what happens is there will be loss of energy, and the loss of energy is given by, that is delta U is given by half CV square. The original formula is actually U is equals to half CV square. In C and V terms only we will write here. This is half C1 C2 by C1 plus C2 into V2 minus V1 whole square. So this is how the loss of energy will be there when you are connecting two charged bodies, two like charged bodies of Q1 and Q2 and capacitors C1 and C2. Now for example, this is in case of like charged body. Now when you are taking an unlike charged bodies, unlike polarities we are taking, and then we are connecting them together, then final common potential what you will get, the same formula here, there is nothing difference here. Even in this case also you will get the same. the common potential V is given by V is equals to C1 V1, but here no, it is unlike charges, no. So C1 V1 minus C2 V2 by C1 plus C2. The only difference is here this is minus and that is plus. Okay. So so this is how the common potential will be. Now for example, what happens when the capacitors are in mixed grouping? Mixed grouping in the sense few capacitors are in series, few capacitors are in parallel, and now the total capacitors, now when you are connecting, what happens? Let us see. Now for example, number of capacitors in a row you are taking. In a row, if number of capacitors in a row if you are taking, then N is equals to desired potential by given potential. Desired potential by given potential. For example, number of such rows, m number of rows are there, for example, then you get M is equals to desired capacitance, means here potential we are taking. Now when you are taking capacitors into consideration, then desired capacitance, capacitors we take by given capacitors into N into N. So this is how it is. Now total number of capacitors, this is the first one is in terms of rows and second one is also rows, but the thing is like in terms of capacitors we are taking, then in such cases what happens? Total number of capacitors is equals to M into N. I know, you know, like you know, M is what and N is what and all that, right? So we have got the formulas, we can put the formulas and then find out the total number of capacitors in rows and in columns and in everything, and then find out the common potential or something like that. So this is how the capacitors are connected in series and parallel. Energy is lost when two capacitors, or when you are taking two charged bodies of Q1 and Q2 of like charges, and then you are attaching it, then you get a common potential. Unlike charges, you are attaching it, then you are getting a common potential, and in both the cases there will be loss of energy, and that loss of energy also we have seen how to find out and all that, right? So this is about the capacitors, and we have started learning these capacitors with the formula of capacitance itself, which is the ratio of charge to the potential, and we have got a unit for it as farad, and we have discussed about the parallel plate capacitor and what happens to a parallel plate capacitor, what happens to the capacitance of a parallel plate capacitor when when different materials of different dielectric constants are introduced with same thickness, with different thickness, when D is vertically, horizontally, D is divided and all that. We have discussed about the new capacitance, how the capacitance is changing in all these cases, and we have also studied about the capacitors in series and in parallel, right? So this is what is the capacitance is. Now we will try to learn how to solve the problems in such cases, okay? And before we go, There's one more formula which we have left in terms of areas. If you have to see, we'll just go to the first thing where we have started. Yeah, you can also use the capacitance formula as C is equals to A epsilon naught by D, which I just forget to tell. A epsilon naught by D. I mean, if you take area, thickness of the capacitance and the distance between two parallel plates, if you are taking into consideration, then you can just see this. And this one changes to this depending upon the situations. Right? I hope it's clear. Okay, let us go back. I told you, right? We will be discussing about few problems. Okay. Charge is 20 microcoulombs, and the potential difference he gave us, that is V is potential difference is 500 volts. Then what is its capacity? So Q is equals to 20 microcoulombs, which can be written as 20 into 10 power minus 6 coulombs, and then V is equals to 500 volts. So we get C is equals to Q by V is equals to 20 into 10 power minus 6 by 500. That is 0.4 into 10 power minus 7. You can also write this as 2 ones 225. Okay, 0.04 microfarad. Okay, so this is the simplest one, and as I told you, we'll go to the parallel plate capacitor and then find out. Yeah. The capacity of a parallel plate condenser consisting of two parallel plates, each of 10 centimeters square, and are separated by a distance of 2 mm. Is dash. So area of a square plate is 10 centimeters square. That is, 100 you get, right? 10 centimeters square, he said. So centimeters, if you if you do it, A is equals to what you will get, 10 into 10 power minus 2 meter square you will get, isn't it, right? And D is equals to 2 mm. He gave, that is 2 into 10 power minus 3. That is two parallel plates, each of 10 centimeters square. Yes. What's the epsilon naught value? You know this? That is 8.85 into 10 power minus 12, isn't it? 10 into 10 power minus, this is 10 power minus 100, no? Square, no? Oh, yeah, sorry. This is 10 power minus 4, sorry. 100 into 10 power minus 4 by 2 into 10 power minus 3. Yes. So if you solve this, you get 8.85, this 10 power minus 12, 10 power minus 16, and then this goes up, it will be 10 power minus 11, right? Yeah. So 8.85 into 10 power minus 11 by 2. So 2 1 are 2, 4.425, 4.425. So the answer is 4.425 into 10 power minus 11. This is the answer. Okay. So this is how we solve the problems. These are only the two example problems what we have solved. But tomorrow in the next class, we will be in detail learning about more problems like how to do and all. So before we end up this session, I just wanted to tell you all that um, you are viewing this particular YouTube channel from the Spark Academy. We have Telegram, we have Instagram pages. You can just join our Telegram by using the link which is given, or you can also go to the Telegram page, just type Spark Academy and then follow, so that too many discussions about the question papers, last year question papers, the questions subject related, and also the courses which are offered by Spark Academy, you will be coming to know in this Telegram link. Right? So there's nothing to actually give the homework, but just go through all the formulas what we have discussed just now. So as I told you, for different notifications, for up-to-date notification, up-to-date information about the Spark Academy, join our different pages, or else you can also call 91, the numbers which are given there, 9133380172 or 8977525461 for JEE EAMCET NEET admissions. Now you can just call this to get more information, or to get the notification about our live YouTube classes. You can just subscribe to our page, and then you can get the live notifications also. Okay. So Spark Academy, this is about chemistry. Sai Kumar sir, and then Chandrasekhar sir, Sandhya ma'am, Vaishali ma'am, biology, Hazira ma'am, maths, Vaisar, and then me. This is me, right? So you can just see our results, last year results, Spark Academy, Telangana EAMCET 2021. Just comparison to the previous years, the result has just gone up. Yeah. Selected into different top 10 colleges who have been selected into all the colleges and all, you can just see here. Okay. And then the highest scores of the Spark Academy NEET students 2022 results 550, 575, and 2021 it is 608. So what is the percentage of selections? 88, 93, and see here 97% of the students are got selected into different MBBS, BDS, and BHMS colleges. Okay, so you can just, this is the advantage of joining in Spark Academy. The fixed programs, and then limited batch size, the well planned academic schedule. This is the proof actually for well planned academic schedule and all that, right? So you just subscribe to our channel for the live updates of Spark Academy. And this is Anupama signing off. Thank you all for joining for today's live session by Spark Academy. Okay, thank you all. We'll see you in the next.